In this video I'm going to show you how to use the bath interferometer, and I've got mine setting on an XYZ stage, and you're going to have an XYZ stage to use the interferometer. And they're very expensive. If you go out and buy one, they're hundreds, even thousands of dollars. Maybe you can pick up one in a flea market like I did, or you can build your own too. Also note that I changed my momentary switch to a toggle switch, so I can turn it off and I can switch back and forth between laser mode and non-lasing mode. I'm going to test a little 4 1/4 mirror that's aluminized, and I suggest you learn how to do this with a aluminized mirror, because everything's so bright, and you can even test it in the daytime. Testing this on my wife's kitchen counter. The first thing to do is to turn on your laser full power and adjust the beam so that it fills out the mirror completely and centered on the mirror. And then if the reference beam is not on the mirror, you make sure that it's lined up with the mirror. It shows up as a dot on the surface like this. If you have a central perforation on your mirror, make sure that you do put the reference someplace on the mirror. Next, you want to find your return reflection coming back from the mirror, and there'll be 2 dots. And the reference beam is the bright one on the left, and the test beam comes to a focus back here. It's on the right, but that's in the wrong spot, because you want the reference beam to focus just slightly behind the beam splitter, which is up here. So you can either move the mirror or move the interferometer back. Okay, so I moved the mirror back a little bit, and now you see that the reference beam is focusing about where I want it, just behind the cube. But it's high, so these are gross adjustments, so you want to get do the gross adjustments on the tripod and not with the fine adjustment screws. So I'm going to move the tripod up. Now with my card, I can see my 2 beams that are too far to the right. The test beam, which is farthest to the right, should fall in the center of the diagonal mirror, and the reference beam is actually falling back on itself. So I can use my adjustment screws to move the interferometer. And I got a piece of Scotch tape on my card here. It helps you see the alignment of the dots from either side, the light coming through either side. So now I got 2 dots here, and we want to line those up, and adjusting the vertical, I can bring up side to side, and then going left to right, I can bring the 2 dots together. Somewhere like that. Now I'll have to look through the prism and see what we're seeing. Okay, so this is my interferogram, and it looks like we're in pretty good focus. If we were out of focus, you would see rings instead of lines, and if I do some adjustment, you can see more or less lines come in here. That's a side to side, and you can adjust them different ways. And if I play with the focus, this is a long F ratio, and focus doesn't change very quickly. Other problem I'm having is this point and shoot camera. The aperture of the lens is pretty recessed far back into the camera, so it's hard to see the aperture of the camera isn't close enough to the points on the cube to pick up the whole thing. So I'm vignetting the outside, but I'm still seeing the whole mirror because it's a low F ratio mirror. If it was a faster F ratio mirror, I wouldn't be seeing the whole thing. And a DSL camera is probably a lot better to use for doing this. On my little Canon lens that I use for videoing, when I zoom it out, the aperture of the camera is deep inside the actual camera front, so that causes vignetting. The best camera to use is one that has a large lens opening and one that you can get close up to the beam splitting cube. Once you get the hang of setting up the bath interferometer, you'll want to use it for testing telescope mirrors. Spherical mirrors will show you straight fringes, but parabolic mirrors will have curvature like this one shown here. You'll want to download an incredible piece of software called Open Fringe, developed by David Rowe and Dale Eason, and it doesn't cost anything. Here's a few screenshots from the software. With it, you can do an artificial null of your mirror and a complete analysis of how good your mirror is. I've traveled o'er this country wide, seeking fortune fair. I've been down the two coastlines, I've traveled everywhere.